Okay, we're starting the last page of the review. It says determine the following for the following graph. Not only do we have the equation, we have a graph where it's graphed on there. It says what is the value of f of 2? For f of 2, we go over to 2 and go straight up here. Value there is going to be 1. You could also plug in 2 wherever you see x here, and you'll also get 1 as well. It says approximate the zeros of this function. Zeros are here and here where they cross the x-axis. This one's pretty close to 2, so let's just say 2.1. And this one's close to 6, a little bit less, so let's just say 5.9. Close enough for me. It says, what is the vertex? Vertex is the point where it changes direction. The point where this changes direction is right here. This is 4, negative 3, 4, negative 3, 4, negative 3, and that's an ordered pair. What is the axis of symmetry? Axis of symmetry is a line right here in the middle. Comes from here. So it is my x value of my vertex. You could also use the equation for the axis of symmetry, x equals negative b over 2a, if you want to use the equation. Write the equation of the parabola in vertex form. I'm going to do that right here. Vertex form, we're going to need to find the a, the h, and the k. So first thing I know is a is 1, and to find h, I'm going to use the negative b over 2a from the vertex here. So negative b over 2a we know is going to actually be 4, but plug those in there so we see how it works. Negative b over 2a. So negative b is negative 8, and a is 1. So that's positive 8 over 2, and that is 4. Again, we also got that from looking at my vertex here. That's 4. And then k is actually my value here, and we know our vertex is right there. So we know this is going to be 3, and the way we can get that doing it by hand is we say k is equal to x squared, and instead of x we're going to put this k in here, 4 minus 8, instead of x we put 4 again, plus 13, and when I put that in the calculator it gives us negative 3. So I'm going to put it into vertex form, a x minus h squared plus k. My a is 1, don't need that, so I start with my parentheses, x minus 4 squared minus 3. That is vertex form, x minus 4 squared minus 3. What is the solution set where f of x is equal to 1? Where is it equal to 1? One of these values right here. So it is going to be 2 and 6. 2 and 6. What is the solution set where f of x is less than 1? Well, everything between these values. So between those values, we can write that as inclusive 2 to 6, or we can say 2 less than or equal to x less than or equal to 6. Either one of those ways will work. Domain and range, this will show up. Domain for all of these, they are always going to be all real numbers. So for the domain, you can either write, again, all real numbers. You can write negative infinity to positive infinity, or you can spell it out. Numbers. For the range, my smallest value, which you can get from here or you can get from the vertex. So negative 3 shows up here again. Negative 3 is my k value here. So we're going to compare it to my negative 3, my y compared to my negative 3, and all the values are greater than, so that's just going to be greater than or equal to. It can also be expressed as negative 3 to, that's inclusive, positive infinity. Either way of those will work as well. If the line negative 2x plus 8 is graphed, there would be where would the two functions intersect? You can set those equal to each other and solve that, or you can just graph that on here. I prefer just to go ahead and graph this on here. So let's graph negative 2x plus 8. Start at 8, down 2 over 1, down 2 over 1, there's an intersection, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, there's the other intersection, and I'm just going to finish this off a little bit. There's the line, intersects there and there. That is 1, 6, intersects there, and it intersects at 5, 5, negative 2. Solve by factoring. I'm going to pull out another sheet of paper again for this. Alright, so we're just going to start. If you want, hopefully you saw that. There they are. Solve by factoring. We are going to start doing the box. If you notice, this has a greatest common factor. I'm going to keep going as if I forgot the greatest common factor. So I have my box. We have 2x squared. We have 50 there. That's what we're going to use to put in our calculator. So in my calculator, I'm going to clear all that off. Remember, when you start this test on Tuesday, clear your calculator so you don't have the mess from the last person in there. We're going to do, in y1, we're going to say a times c divided by x, and in y2, we're going to have a times c divided by x plus x, and then in my graph, I'm going to look for b. Alright, so let's start plugging it in. A is, let's say 2 times c, which is 50. And those are the things we put in the graph in the table first. We're going to divide that by x. Then we're going to do the same thing, 2 times 50 divided by x, and add the plus x on here. Look at my table, and we're going to be looking for b, which in this case is 20. Scroll down until we find 20. Oh, 20 in y2. So we have 10 and 10. Must be a perfect square. So we end up with 10x and 10x. To factor this, we go ahead, we look right here, first one, they both have a 2 in common, and they both have an x in common. I do not factor this way now. I go ahead and pretend this is a puzzle. What do I need to multiply 2x by to get 2x squared? Well, I just need to multiply it by an x. Now, what do I need to multiply 2x by to get 10x? I just need to multiply it by 5. Now, what do I need to multiply x to get to 10x? Well, that's going to be 5. Sorry, not 5. This is going to be 10. And then I check to make sure I did it right. 10 times 5 is 50? Yes. There are my factors. Write the bigger one first, or the bigger initial leading coefficient value first. 2x plus 10, x plus 5. It's going to be a multiple choice test that you're going to have on Tuesday. If you see this, if you get this, you're not going to find these solutions. Because remember I told you at the beginning, we have a greatest common factor. My greatest common factor was a 2 up here. That 2 now comes into play in this factor set over here. There's a 2 in this factor. So this one stays the same. If I factor 2 out here, and that's x. Factor 2 out from this, and that's 5. Those are my factored forms. This right here are my factors. 2, x plus 5, x plus 5, or I could say 2, x plus 5 squared. I'm going to take this one step farther and say we're going to solve this. Oh, it does say solve. Never mind, it says solve. That's factored form. When I get this solved, I am going to split it in half, say x plus 5, and set those equal to 0. And by the way, all of these should have equal to 0 since we have that equation. You'll notice these are the same. Because this is a perfect square in here, I can get rid of those. I don't need 2 because it's the same. Why do it twice? X is equal to negative 5. So my solution is x is equal to negative 5. Next one is not as long. It's actually a difference of squares. You can do it by difference of squares just by looking at take the square root of both of them, since it's minus in here. It'll be x plus 6 and x minus 6. Oh, can you see that? X plus 6 and x minus 6. I'd rather, if you don't remember that, just go ahead and do the box method. So, box x squared minus 36. And let's go ahead, plug all this in the calculator and see what happens. A value is 1. This value is negative 36 for my C. 1, negative 36. And I'm going to look for what number. If I look at my table, what is my B value? There is no X term. If there is absolutely no X term, I'm looking for 0 in Y2. There it is, 6n negative 6. 6x, negative 6x. At this point, I can go ahead and factor. Let's go ahead and factor right here. This has an x. X times x, x squared. 6, negative 6. Right here and here are my factors. X minus 6 equals 0. And x plus 6 equals 0. Pop that down. Add 6 to both sides. X equals 6. And this one over here, x plus 6. So we're going to subtract 6. X equals negative 6. Those are my solutions. X equals 6 and x equals negative 6. And finally we have the last one. A penny is dropped from a tower. If the function that represents the height in feet of h of the penny t seconds after it is dropped is blah blah blah, for what approximate time values will the height of the penny be less than 50 feet? So we want to know when the penny is going to be less than 50 feet. Here's my equation. If I was setting this up, it'd be 16 t squared plus 76 is going to be less than 50. Let's go ahead and look at this in the calculator. We're just going to put this in, clear, negative 16x squared, remember we put x's not t's in the calculator, plus 76, and we put 50. So basically I want everywhere that this over here is less than 50. Now, in a real situation, we're typically always going to start at 0, because it's not going to make sense for me to say the penny after negative 3 seconds is going to be less than 50, or negative 2 seconds is going to be less than 50. It doesn't work that way. So we're going to have to figure out here is everything after about 2 to 3 seconds is going to be less than 50, because 60 is greater than, 12 is less than. So between 1 and 2, it changes. So we're actually going to have to go ahead and solve this to find the exact value. But if it was multiple choice again, if you had like a 1.5, x is greater than 1.5, or time is greater than 1.5, that would be the one to choose. Let's go ahead and solve this, and then we'll just say everything greater than that number. To solve this, I'm going to pretend this is an equal sign for the time being. I'm going to scoot this over, negative 16t squared, subtract 50 from both sides, plus 26. right? Yeah. Equals 0. And then you can plug that into the quadratic formula. These up here can always be used by quadratic formula. Anything you want to do to solve for zeros or anything solving for a quadratic function, you can go ahead and just put it in the quadratic formula. So we have negative b plus or minus the square root of b squared minus 4ac all over 2a. A, B, C. What are we going to make A, B, and C? A is negative 16. B, I don't see B, so that's a 0. And C is 26. B is 0. B is 0. A, C, A. I'm going to go ahead and plug this in the calculator. There are some zeros here. I don't care about the zeros, but I'm going to show you how to put them in. You don't have to put them, but I want to show you how to put them in just to make sure you understand how they would go. Negative 0 plus the square root of 0 squared minus 4 times negative 16. The negative in the middle, or minus, is the gray one. The ones in front of these are the white ones. 16, and this is 26. Now we can go down 2 times negative 16. Enter, and that's what it's going to be. Here's my marker. So we have 1 at negative 1.27. And then we also have 1. We're going to go back up twice, hit enter, copy it, scroll on over to the plus, make it the grade subtraction, and that's going to be positive 1.27. So my solution would have to be pinning less than 50. So that's anything where the time is greater than 1.27. Again, if it's multiple choice, you could just kind of look at that first graph. This is how you would solve it with the quadratic formula. And that is all of the review.